In the last lecture, we were talking about different types of problems which are based on vectors. Let us have some more problems which are based on elementary basic concepts in vectors. This is one simple problem. If AB bar is equal to 2i minus 4j plus 7k and initial point A has coordinates 1, 5, 0, then find the terminal point B. Means we are asked to find coordinates of point B. Coordinates of point A are given and vector represented by AB bar is also given. Let us see how to find this. So this is given information. Now, since coordinates of A are 1, 5, 0, we may assume that A bar is equal to I plus 5j plus 0k. And B bar is the position vector of point B. We know that AB bar can be written as B bar minus A bar. Now we want to find B bar. AB bar is given. AB bar is 2i minus 4j plus 7k. A bar is also given. We can find B bar. Just shift this vector to left side and this is value of B bar. So this is how we can find position vector of B, and from position vector of B we can find coordinates of B. They are 1, minus 9, 7. Next sum, show that following points are collinear. Now this is a typical type of question, and many times this type of questions are asked in board exam. Collinear, points coplanar, and there are several methods to prove that points are coplanar and points are collinear. Now here two sets of points are given. We will solve one problem at a time. So in first problem, points are A, B, C, and these are coordinates of points. We write their position vectors. Position vector of A having coordinates 3, 2, minus 4 is written as 3i plus 2j minus 4k, and similarly position vectors of B and C are written. Now we write AB bar. AB bar means B bar minus A bar. We have B bar, we have A bar, so we can calculate AB bar. This is AB bar. Similarly, we find AC bar. AC bar means C bar minus A bar. We have C bar, we have A bar. So subtracting A bar from C bar, we get AC bar. So this is my AC bar and this is my AB bar. Now just look at this AB bar and AC bar. AB bar and AC bar. Just observe them. Now, after observing AB bar and AC bar, we see that this AC bar, I will take minus 5 common from AC bar. Let me take minus 5 common, and this is multiplied and divided by 6. So minus 5 by 6 into 6i plus 6j minus 6k. But this vector 6i plus 6j minus 6k is AB bar. So AC bar is equal to minus 5 by 6 times AB bar. That means one vector is a scalar multiple of other. AC bar is scalar multiple of other. That means they are parallel. AC bar and AB bar are parallel. Vectors are parallel. And they have one point A common. That means they must be collinear. That means points A, B, C must be collinear. Points A, B, C are collinear. So this is how to show that points are collinear. Let us look at the steps. First step is we write given points, write their position vectors, Find AB bar, find AC bar. You can take BC bar also. You try with instead of taking AC bar, you take BC bar and try to solve this problem. Now, after writing these position vectors of points, we write vector AB bar, vector BC bar, and show that by doing little adjustment, we can show that one is a scalar multiple of other. Now, when vectors are scalar multiples of each other, they are collinear, and therefore points will become collinear. Now, for the second set P, Q, R, you work out the calculations and verify that points are collinear. I will move to the problem of coplanarity. मी कोप्लेनॅरिटीच्या प्रॉब्लेमकडे जातोय. हा पी क्यू आर कोलिनियर दाखवण्याचा जो प्रश्न आहे तो तुम्ही करायचा आहे. इफ वेक्टर्स 2i minus qj plus 3k and 4i minus 5j plus 6k are collinear, then find value of q. Now given vectors are collinear means one is scalar multiple of other. I have named them as a bar and b bar. Now it is given that they are collinear. That means b bar must be scalar multiple of a bar. So let me write b bar is equal to t times a bar for some scalar t. I put value of b bar, value of a bar, simplify, and now equate the coefficient. Two vectors are equal if their components are equal. That means this 2t, which is coefficient of I, must be equal to 4, which is coefficient of I in the left side. Coefficient of j in the right side is minus qt, and this minus qt must be equal to minus 5, and 3t must be equal to 6. So this gives me t is equal to 2. This also gives me t is equal to 2. And if I put t is equal to 2 here, t is equal to 2 here, I get 2 into this q, or q into 2 is equal to 5. Cancel this minus sign. And from this I can find value of q. So question was, two vectors were given and it was mentioned that vectors are collinear, and we were asked to find value of q. This is value of q. Problem is over. Let us move to the next question. Question is, are the 4 points A, B, C, D coplanar? Justify your answer. We are asked to check whether points are coplanar or not. As usual, we first write their position vectors using their coordinates. Using coordinates of A, B, C, D, we write position vectors of these points. Then we calculate 3 vectors: AB bar, AC bar, and AD bar. We calculate 3 vectors: AB bar, AC bar, and AD bar. How we write AB bar? AB bar is equal to B bar minus A bar. We have B bar, we have A bar, so we can write vector AB bar, AC bar, AD bar. Now, if points A, B, C, D are coplanar, then there exist scalars x and y such that AB bar is equal to x times AC bar plus y times AD bar. We know 3 vectors are coplanar. If 3 vectors are coplanar, AB bar, AC bar, AD bar, then each of them can be expressed as linear combination of other two. Each of them can be expressed as linear combination of other two. points A, B, C, D are coplanar if and only if vectors AB bar, AC bar, AD bar are coplanar. So we assume that these points are coplanar, and because of that we have this equation. Now if we simplify this equation and equate the coefficients of I, J and K in left side and right side, we get three equations. One equation for coefficient of I, one equation for coefficient of J, and one equation for coefficient of K. Now we check whether these equations are consistent or not. Now what is meant by equations are consistent or not? Same value or same set of values of x and y must satisfy all three equations. They should have common solution. Now first equation says y is equal to minus 3 and third equation says y is equal to 0. Now how is this possible? How is this possible? This is not possible. Y is equal to minus 2 and at the same time y is equal to 3. This is not possible. Now we may say that this is a contradiction, and this contradiction, y is equal to minus 2 and y is equal to 0, this is a contradiction, and this contradiction has arisen because of our wrong startup. Our startup was points A, B, C, D coplanar, and assuming that they are coplanar, we have written these equations. So this assumption is wrong. Its opposite is true. What is assumption? A, B, C, D are coplanar. This is wrong, and therefore A, B, C, D are not coplanar. This is correct. This is right. Okay. So this was coplanarity problem using coplanarity of points. We came to coplanarity of vectors, and vectors are coplanar if each of them can be expressed as a scalar multiple of other two, linear combination of other two, and we use this fact for coplanarity of points. Now here is one problem. Express vector minus I minus 3j plus 4k as linear combination of these three vectors. Express this vector as linear combination of given three vectors. Now this is possible if these three vectors are non-zero and non-coplanar. We have theorem that if we have three vectors a bar, b bar, c bar which are non-zero and non-coplanar, then any vector r bar can be expressed as linear combination of a bar, b bar and c bar. So this given vector will play the role of r bar, and remaining three vectors will play the role of a bar, b bar and c bar, and we have to express this r bar as linear combination of a bar, b bar and c bar. Now we substitute the given vectors in their place. In place of r bar we write first vector, in place of a bar, b bar, c bar we write their respective values. Simplify means collect the coefficients of I. Now here coefficient of I is 2x, here coefficient of I is 2y, here coefficient of I is 3z. So coefficient of I in right side is 2x plus 2y plus 3z, and this must be equal to coefficient of I in the left side, which is minus 1. Similarly, we collect coefficients of j, coefficients of k, and equate them with coefficients of j and k in the left side. Equating them, we get these three equations. Now we check means actually solve these equations by using Cramer's rule. You can use matrices method also, you can use elimination method also. different types of methods are available and you can use any of them to find the values of scalars x, y, z. I have solved them by using Cramer's rule. I found that x is 2, y is 2 and z is equal to 3, and these three values satisfy all three equations. So I put them in this equation. R bar is equal to xa bar plus yb bar plus zc bar, and now my given vector R bar is expressed as linear combination of a bar, b bar and c bar. This is possible because given vectors a bar, b bar, c bar were non-zero and non-coplanar. Okay, now show that 3 points A, B, C are collinear. We have already solved one problem of collinearity. We write position vectors of points A, B, C. We find two vectors AB bar and AC bar. Here I have calculated AB bar and here AC bar is written. We observe that AB bar and AC bar are very much similar. Only change of sign is there. So we take -1 common from this and get AB bar in AC bar. That means AC bar is -1 times AB bar. So we conclude that AC bar is scalar multiple of AB bar, and therefore AC bar and AB bar are collinear vectors. They are parallel vectors and they have point A common. And therefore points A, B, C are collinear. So we solved two problems of the same type. I have left one problem for you to show that points P, Q, R are collinear. Again I must mention this thing, that problems of collinearity and coplanarity are very much famous for board exam. That means in board exam many times these types of questions are asked. Okay, now next sum, show that three vectors are given and we are asked to show that these three vectors are coplanar. Now what was last problem? 3 points are collinear. 3 points collinear. Now this problem is 3 vectors are coplanar. We know 3 vectors are coplanar if each of them can be expressed as linear combination of other two. Each of them can be expressed as linear combination of other two. So I have named them as A bar, B bar and C bar, and I write A bar is equal to M B bar plus N C bar. Let us write A bar as linear combination of B bar and C bar. If scalars M and N exist, non-zero scalars M and N exist which satisfy this equation, then that is sufficient to say that vectors are coplanar. So our aim is to find values of M and N, or to check whether values of M and N exist or not. So we put value of A bar, value of B bar and value of C bar in this equation. Then collect the coefficients of I, M plus 2n, J minus 2m plus 3n, and coefficient of K, 3m minus 4n, and equate these three coefficients with coefficients of I, j, k in the left side, and equating them, we get these three equations. After solving these three equations, actually there are only two unknowns, two constants, so it is sufficient to solve any two of them. So solving any two of them, we get m is equal to -2 and n is equal to 3, and we verify that m is equal to -2 and n is equal to 3. M is equal to -2 and n is equal to 3. 3 into -2, -6, and n n is 3. So -4 into 3, 4 3s are 12. This is -12 and this is -6. -6 plus -12 is -18, means values of x, m and n which are obtained from first two equations, these two values, they satisfy third equation. So equations are consistent. That means they have common solution. System has common solution, and therefore factors are coplanar. A bar is expressed as linear combination of B bar and C bar. Therefore A bar, B bar and C bar are coplanar. So this is how to show that factors are coplanar. So we have studied how to prove that points are collinear, how to show that factors are coplanar, how to show that 4 points are coplanar. आपण 3 प्रकारचे प्रॉब्लेम आता केले. 3 पॉइंट कोलिनियर आहेत, हे कसं प्रूव्ह करायचं. 3 फॅक्टर जर असतील तर 3 फॅक्टर कोप्लेनर आहे ते कसं दाखवायचं. आणि 4 पॉइंट्स असतील तर ते 4 पॉइंट कोप्लेनर आहेत हे कसं दाखवायचं किंवा व्हेरीफाय करायचं हे आपण पाहिलेलं आहे. आता जॉमेट्री मधले काही प्रॉब्लेम आपण फॅक्टरच्या मदतीने करणार आहोत. We will solve some problems from geometry with the help of factors. In quadrilateral ABCD, M and N are midpoints of diagonals AC and BD. M and N are midpoints of diagonals. Show that AB bar plus AD bar plus CB bar plus CD bar is equal to 4 times MN bar. Now we will do this by using triangle law of factor addition and midpoint formula. So AB bar is equal to AM bar. Where is M? Here is M. Here is point M. Let me show point M. Here is point M. And this segment AM is same as segment MC, because M is the midpoint of AC. Now what I have written, this AB bar is AM plus MN plus NB. This is called polygonal law. Then I write AD bar. This AB bar is expressed. Now AD bar. This AD bar you can look at AD bar. AD bar is AM bar, AM plus MN plus ND. So moving a particle from A to M, then shifting it from M to N, and then from M to D. is equivalent of shifting a particle from A to D. So we have this second equation. Now for third equation, CB bar. CB can be viewed as CM plus MN plus NB. So shifting a particle from C to B, equivalent of shifting it from C to M, M to N and N to B. Finally it will be at B. And similarly, I have expressed this CD bar also. CD bar is CM plus MN plus ND. And now in this equation, if I start from left side and if I replace this AB bar, AD bar, ACB bar, CD bar by these expressions, I get this equation. And in this equation, I observe that AM bar plus CM bar is equal to 0. This AM and CM, they are opposite vectors. So their sum is 0. Their sum is 0. Now here also I have AM bar and AM bar, and to cancel this I want CM bar. This is CM. Then this NB and ND, they are opposite vectors. So this NB will get cancelled with ND. This NB gets cancelled with MD. And finally what remains? Here MN. Here is one MN. Here is one MN. And here is also one MN. So 1, 2, 3 and 4. So this sum of these 4 vectors is equal to 4 times MN bar. This is equal to 4 times MN bar. किती मोठे कॅल्क्युलेशन इथे लिहिलेले आहे, तेवढ्याची काहीच गरज नाही हो. इथे मी तुम्हाला एका लाईन मध्ये दाखवलं सगळे कसे कॅन्सल झालेले आहेत ते, आणि 4 टाइम्स MN बार आलेले. ओके, यू हॅव स्टडीड दिस प्रॉब्लेम इन 9th स्टँडर्ड. आपण हा 9वी मध्ये अभ्यासलेला प्रॉब्लेम आहे, तोच प्रॉब्लेम आपण परत इथं करणार आहोत. फक्त आता आपण फॅक्टरची मदत घेणार आहोत. प्रूव्ह दॅट line segment joining midpoints of two sides of a triangle is parallel to the third side and is half of the third side. So this was one famous theorem in geometry. If we have a triangle, then if we have any triangle, and in that triangle, if we take midpoints of two sides and segment joining them, this segment is parallel to the third side and its length is half of the length of the third side. So this problem we have to solve by using factors. Let triangle be ABC. Let M and B midpoints of AB and AC respectively. Then AM bar is equal to half of AB bar. AM bar is half of AB bar. Why? Because M is midpoint. Similarly, AN bar is half of AC bar, midpoint. Now, this AN can be viewed as AM plus MN. AN is equal to AM plus MN by triangle law. So this MN is AN minus AM. So I write MN as AN minus AM. Now just now we have seen AM is half of AB bar and this AN is half of AC bar. So make use of these two relations in this equation and take this half common, and I get MN bar is equal to, taking this half common, inside bracket we have AC bar plus AB bar. I have changed this minus AB bar into BA bar. I have changed this minus AB bar into BA bar. Half is taken out. Now BA plus AC, you can see in figure BA plus AC. That means shifting a particle from B to A and then from A to C is equivalent of shifting it from A to C. So sum of this BA plus AC is BC. So Mn is equal to half BC. Now look at this vector equation. Mn is equal to half BC. Now when two vectors are equal, actually two vectors are equal. Which two vectors? Mn bar and half BC bar. But if we are talking about Mn bar and vector BC bar, then they are parallel vectors. Mn bar and BC bar are parallel vectors. So segment joining midpoints Mn is parallel to BC. And if we compare the magnitudes, magnitude of Mn bar is half the magnitude of BC bar. Magnitude of Mn bar is half the magnitude of BC bar. And therefore we can say length of the segment Mn is half of the length of the segment BC. So this was one problem from geometry. This way we can solve the theorems using vector. Some more theorems and their solutions are given in textbook, in exercise. Some of them are, you'll find some of them in exercise also. So you try to solve the remaining problems. I have tried to solve almost all problems in first exercise and I have discussed solve examples also. Now in the next lecture I will move to next unit, sub-unit in chapter vector, and its name is section formula. Its name is section formula. One complete exercise is there on section formula. So in the first lecture we will discuss proof of the section formula, and in next lecture after that we will see the applications of section formula. Problems in geometry can be solved by using section formula. तोपर्यंत नमस्कार.